As is well known, the territory of the former Soviet Union covered 1/6 of the Earth's land surface. Most of the USSR's area consisted of endless forest expanses of taiga, the permafrost of the tundra, and the cold deserts of the Arctic. To provide connections between isolated settlements, which were not linked to each other by paved roads and were spread out hundreds of kilometers apart, as well as to support the operation of numerous mining enterprises stretching from the vast Siberia to the far north. Leading Soviet automobile companies would go on to develop incredible all-terrain trucks, remarkable in their design, which would mostly be based on mass-produced serial models. The 1950s would become an especially fruitful period for the development of such vehicles. These all-terrain vehicles would be developed primarily as military trucks to provide logistics in off-road conditions and hard-to-reach areas of the Soviet Union. Most of them would remain at the stage of individual prototypes, which would eventually disappear somewhere or be scrapped for metal. All that will remain of them are faded photographs and black and white footage from newsreels, which will testify to the interesting approaches Soviet engineers took in designing such vehicles. Here are a few striking examples of such vehicles. ZIS E134 is a multi-purpose, four-axle experimental vehicle with extremely high off-road capability. The vehicle's design incorporated original technical solutions to optimize load distribution on the wheels and enable it to overcome difficult obstacles. The drive axles on the vehicle were evenly spaced, 1.5 meters apart from each other. Additionally, in the four-axle configuration, the wheels of the two front axles were made steerable. This model remained experimental and never went into production due to changes in the military department's technical requirements. Based on the ZIL-136 truck, engineers at the Likhachev plant in Nami would create a three-axle wheeled snow and swamp vehicle with a monocoque body. The experimental model would be equipped with a ZIS-110 gasoline engine, borrowed from a passenger car. The engine would have a displacement of 6 liters and an output of 140 horsepower. In front of the engine, a 3-speed manual gearbox from the same ZIS-110 would be installed. In the middle part of the vehicle, there would be a crew cabin with several seats. The gearbox and engine occupied the middle and rear parts of the body. The vehicle was additionally equipped with a water jet propulsion system, which was powered by a separate power takeoff shaft. The all-terrain vehicle would have a 6-wheel running gear with a rigid wheel suspension. The shock-absorbing function was performed by low-pressure tires, which compensated for all surface irregularities. The vehicle's wheels could be fitted with tires of various sizes and shapes. In particular, the use of arch tires was envisaged. Special modifications of the all-wheel drive ZIL-157 trucks were also equipped with arch tires and a 3-axle layout with evenly spaced axles. The ZIL-157R modification. On February 23, 1960, the Likhachev plant presented the experimental all-wheel drive truck ZIL-132. The vehicle was to be equipped with a carbureted V8 engine producing 180 horsepower. The transmission is a mechanical 5-speed, additionally equipped with a 2-speed demultiplier. The truck's chassis is 3-axle with evenly spaced axles and is fitted with wide arch tires. The vehicle's weight is 9 tons 880 kilograms, with a payload capacity of 2.5 tons. The truck could accelerate to a maximum speed of 67 kilometers per hour. In 1974, a model with a cab-over engine design was released, the ZIL-132PE. This model would serve as the basis for the all-wheel drive truck tractor's ZIL-132RV. In 1932, based on the ZIL-132 truck, an amphibious all-terrain vehicle model, the floating ZIL-132PE, would be created. The vehicle would be equipped with a sealed underbody and chassis, a cab-over-cab, and a tarpaulin-covered cargo bed with a 4-ton payload capacity. The truck would be produced in small batches. As an experiment, small gas turbine engines would be installed on this truck. The vehicle was intended for the search and evacuation of cosmonauts and space capsules after their landing in hard-to-reach areas. Using arch tires, Nami would build another experimental tractor, the Nami 044, in 1958. The vehicle would have a 4-wheel drive, 4x4, configuration, a bonnet 2-seater cab, and a short wheelbase. A short ballast body was placed at the rear of the vehicle. The front suspension of the tractor vehicle was dependent, using 2 longitudinal leaf springs. The rear suspension was rigid. The shock-absorbing function was to be performed by wide, low-pressure balloon tires. Thanks to the ballast, the weight of the tractor could vary from 3,200 kilograms to 8 tons. The increased weight improved the vehicle's traction and coupling characteristics. The tractor was to be equipped with an SMD9 diesel engine producing 75 horsepower and a 5-speed automotive gearbox. The vehicle was intended to be used as an artillery tractor and for field work, serving as a partial replacement for the DT-54 track tractors. Later on, the tractor would be sent to the Kharkiv tractor plant, where it would serve as the prototype for the wheeled T-125 tractor. The engineers would also experiment with the running gear of both small passenger off-road vehicles and all-terrain trucks. One such experiment would be the installation of track drives with pneumatic suspension on the rear drive axles of off-road vehicles like the Moskvich 415, the special half-track modification S3, and the JZ69M off-roader, model JZ69MT3MU. Another interesting all-terrain truck with an unusual chassis will be developed at the NAMI experimental plant. The model will be named ET8 Urugan. Its design will be borrowed from an American model by the 4-wheel drive company. The all-terrain vehicle will have a special chassis design, in which, instead of the usual wheel or track system, 8 pneumatic rollers with a diameter and width of 1 meter 20 centimeters will be used, mounted 4 each on 2 balancing carriages. A standard 8-seat cab, borrowed from the ATS medium artillery tractor, will be installed at the front of the vehicle. The ET8 was equipped with a ZIL 375 V8 gasoline engine producing 180 horsepower. The engine was installed behind the cab in the body and covered with a hood. Behind the engine, a cargo platform with a load capacity of 8 tons 600 kilograms will be installed. The all-terrain vehicle's transmission was assembled from standard units of the MAZ 501 truck. The vehicle had all-wheel drive, with the first and third axles being able to be disconnected from the drive. Each roller was set in motion by a complex system of gear wheels, which were called a guitar. The rear running gear carriage was attached directly to the frame. In contrast, the front carriage, which was steerable, was attached to the rotary support mechanism. The vehicle was equipped with a MAZ 200 steering mechanism and a power steering unit from the MAZ 525 truck. The truck would undergo all the necessary tests and demonstrate good driving performance. Thanks to the large contact area of the pneumatic rollers, the vehicle would exert low specific pressure on the ground. The all-terrain vehicle was intended to be used for transporting rocket weaponry in hard-to-reach areas. Despite its decent driving performance, the all-terrain vehicle would have serious drawbacks. Its weight reached 21 tons, which was twice as much as the American counterpart. The large weight will negatively affect the vehicle's maneuverability and handling. In addition, it will have low compatibility with standard production vehicles. Perhaps the biggest drawback will be the complex and unreliable transmission design, which will frequently break down. The technical shortcomings listed above will be the reason why the NAMI ET8 all-terrain vehicle was not adopted by the Soviet Army. Specialized modifications of the serial all-wheel drive ZIL 132 trucks will also be built on pneumatic rollers. They will experiment not only with the running gear of all-wheel drive trucks, but also with the engines. As we can see, the Soviet Union, with its far from the best road network in the world, needed a variety of all-terrain vehicles that could be used both in defense and in civilian sectors. However, the low technical base of the Soviet automotive industry, as well as bureaucratic obstacles, would ultimately prevent many promising projects from reaching mass production.